Practice problems. Number 1, an ant crawls 40 centimeters south and then 20 centimeters west. What's the final distance and displacement for the ant? Alright, so it's going to look something like that when you draw this out. And now it says what's the final distance and displacement for the ant? Well, the distance, remember, is just a scalar quantity. That's going to be pretty easy. So the distance is just from where you started, and you're just adding them all together. You don't care about what direction. So distance, d, is going to just be equal to 40 centimeters plus 20 centimeters. So it's going to be equal to 60 centimeters. So pretty simple, right? As long as you recognize that distance is just adding them all together because you don't care. All right, displacement is going to add a little arrow over top because it's a vector quantity. Technically, that should add a little change in too. So my displacement that I'm looking for is this, right? So this is going to be the tougher question. So now what we got to do is Pythagorean theorem first. So this is going to be, I got an update. So this is going to be d squared, I'm just doing Pythagorean theorem, is equal to, and it's going to be 40 centimeters squared. Oh, other side of the brackets. Plus 20 centimeters squared. So d is going to be equal to, so it's going to be 44.7. So that's going to be my magnitude, but technically, actually, my answer should only be 45 because of sig digs here. Got a problem with that in some of these. Okay, anyway, 44.7. And then the last thing we got to do, though, is I got to figure out what this angle is. And the way we do that, remember, so we're talking about like our Cartesian plane there. So if this is south, this would be west. So I know it's going to be south and west. It's going to be south of west. I know that right away, but I can figure out that angle. So what we got to do is look at, okay, I've got the opposite and I've got the adjacent side. So I need tan, just like the one we did before. So I'm going to go tan theta is equal to, opposite is 20 meters or centimeters. Adjacent is 40 centimeters. So theta, or the angle, is going to be equal to tan, or the inverse of tan, 20 centimeters over 40 centimeters. So theta is going to be equal to 63. Actually, I lied. It's not 63. It's 27. 27 degrees. Now, how does that make sense? Because the answer here says 63. Well, they're actually both right? That's what we were talking about before. So the answer here, myself some room there. The answer here would be 44.7, forgot the units there, centimeters, and then it's going to be 27 degrees. And now this answer said south of west, but our answer is going to be west of south. And you can see why this, because this is the angle that we were talking about, right? So it's going to be west and south of the two we're dealing with, but this one's like of the south. It's like coming from the south. So that's our answer there. But the answer that they have up here, 60 degrees south of west, that would just be this one, right? So this is 63 degrees, and that would be south and then of the west. So they're both right. All right, moving on. Okay, a car is driven 80 kilometers north, then 50 kilometers east, then 30 kilometers south, and then 90 kilometers west. The entire trip requires 4.5 hours. What was the average speed and displacement of the car? So the average speed one's going to be pretty straightforward because speed is a scalar, right? We just need the distances. So all I got to do is add up all these distances. Doesn't matter about south or west or anything like that. So we've just got, so if you just add up all your distances there, just everything, and then you get 250 kilometers. Now speed, so V without the arrow on it, is going to be distance over time. So that's just going to be 250 kilometers over my total time of 4.5 hours, which is going to be 56 kilometers an hour. All right, part one done. Now for this one, I'm just going to start This is our starting point right there. And I'm just going to put them all together, kind of show you what we're going to do here. So just bear with me. I'm just going to draw this all out. So we got 80 kilometers, and then doing tip to tail, the next one's going to be 50 kilometers east. So I drew that one in green. I'm going to draw all the ones east and west in one color and all the ones north and south in the other. So I'm going to draw the one going 30 kilometers south now. All right, so this is really what we got going on, right? And what we're after here is going to be the vector from there to there. That's what we're after in the end, right? That's the displacement of this thing. Now, we can make this a lot simpler by before making this, if we just subtracted everything or just added together everything north and south and everything east and west. So what I mean by that is the red parts here, let's just make this simpler by going, well, 80 was up and then 30 was down. So let's go 80 minus 30. Let's just make one vector. And it's not a straight line now, but anyway. So I want 80 minus 30 to get 50 kilometers. So that's the net result of everything going in the north and south direction, right? Now, everything going the east to west direction, I've got, well, 50 and then minus 90. I'm going to end up with negative 40. So 40 in this direction. So this ended up being 40. So in the end, we ended up with the exact same resultant vector. We're still looking for the same thing, but now we have numbers that we can kind of deal with. So that's going to be your best method, is everything north and south, add them together to figure out what the net result is. Everything east and west, do the same, and then make a triangle out of that. And then we've still got, this is going to be our angle, and then we just got to use Pythagorean theorem to figure out what this is. So if we do that, just using Pythagorean theorem, I can say that the displacement is going to be equal to, so that's going to be 64 kilometers. And put the reason test to it too, right? 64 kilometers, if you go through it and you get like some kind of wonky answer like 1,000, this obviously can't be 1,000 if the two sides are 40 kilometers and 50 kilometers, or it also couldn't be 30 because the hypotenuse has to be longer than those two. So put the reason test to that. And you might be asking yourself, well, how do I know if that's negative or positive? The resultant vector here that we're dealing with, the one that's going to be on angles, it's never going to be negative or positive, right? It's always going to be positive it as a number. But then that's the whole reason that we are going to put something after. That's why we're going to put the degrees after. All right, so that's what we got to do next. We got to figure out what the angle here is. So it's going to be tan. They pretty much all are if we got the adjacent and the hypotenuse or in the opposite sides. So this would be, let me write this down here maybe. Tan theta is going to be equal to 40 kilometers over 50 kilometers. So theta is going to be equal to tan, or inverse tan, of 4 over 5. And you might be saying, Mr. Brown, you forgot the units, but the units canceled now, right? They canceled, and one of the zeros canceled. Anyway, if you go inverse 4 over 5, you get 38.7 degrees, so 39 degrees. Oh yeah, and one more thing. If you end up getting you do the exact same thing in your calculator and you don't get this for an answer, make sure that your calculator is in degrees. It's not going to work if your calculator is in radians. If it's brand new, it's probably in radians. So ask your math teacher how to take it out of radians. All right, so that's going to be theta is equal to 39 degrees. So now our answer here is going to be, the displacement is going to be equal to 64 kilometers, 39 degrees. And now what are things going to be? Well, if this was where we started, that was north, and this is going to be west. This is going to be west, and then of the north. It's like it's coming from the north. So 39 degrees west of north. And again, you might look up to the answer for this one, and it says 51 degrees north of west. That works too. They're both right. So I'm going to end that video there. I'd like you guys to go ahead and do these review of trigonometric functions. This is all review, but you will really need to be... Oh, that was weird. Go back. 7. Yeah. You will need to be doing trigonometry here. So however you've been doing trigonometry, keep doing it. Like if you're using SOHCAHTOA, that's great. If you're using these ratios, which are really the same thing, just a different way of writing it, do that. And then do this trigonometry review. I said this is optional. If you think your skills are great, then that's awesome. If you think your skills are kind of wanting, I would definitely do this, because this isn't going to be the last time we're doing trigonometry. It's going to come up over and over and over again. So get good at this trig identity stuff. And then the hand-in assignment. So go ahead and do the hand-in assignment. When I say scale diagram, like I do in number 1, that's where you're measuring with a ruler. So go back to the earlier part of this video and find out where we did that. So you need to make a scale. Okay, and then that should be pretty much it. And then that one, yeah, that's a great question. I like that one. Okay, so that's it for that video. I'll see you guys in the next one.